And the person who is going to speak to us now also happens to be one of the most entertaining lecturers, not just in this space, but in the area of human health generally, who I have ever encountered. So we are very, very fortunate to have, for quite an extended period of time now, we're getting our money's worth out of him this afternoon. We're going to put a bit of an intermission or a break in the middle of a session that could go on for well over an hour. But let me introduce, hopefully standing by, ready and primed and feeling very energetic, his gut health in very, very good order, Dr. Zach Bush. Hello, good afternoon, Zach. How are you?
I am wonderful. Very good to be with you all.
Thank you so much for joining us. So I'm not going to get in your way. Please do just set out your stall.
Very good. Yeah, very glad to be with you all. I'm a medical doctor here joining you from a wandering path of my career that has taken me deep into the story of human health and disease through Western medicine as a medical doctor, MD trained in internal medicine, then endocrinology and metabolism, which is the study of the way energy moves through biologic systems, as well as how the body coordinates that energy into a symphony of life that we would experience. And so that journey took me ultimately into the food systems and deep into agriculture. And so that's been the journey here. But I'm ready to jump into slides if that feels right. I'm going to share a screen here. All right. I think that's got you into it. I recently came out of the rainforest in the Amazon, taking a look at the history of kind of human biology within natural systems was part of the mission down there. But a deeper mission was to really reintegrate my understanding of agriculture and food systems, as well as my own spiritual development around indigenous understandings of our oneness, our connection ultimately to natural systems. And so we spent time with the Achuar people who have been living in the Amazon about the same period of time that the Aboriginal peoples have been living in the Australian area of the world. And it's about 40,000 year history to their peoples. And so 40,000 years of time living in the same roughly million acres of the rainforest in the sacred headwaters of the Amazon basin. This is a rainforest that covers a space greater than 2 times the surface area of India as a nation. And so this vast ecosystem is a semblance of what the whole planet looked like at one time. And interestingly, when you go step into the kitchen in one of their traditional homes, on one end of these large open-aired homes, you have their fire pit and kitchen. And it's notable because there's no storage bins, there's no refrigerator. Instead, they walk out in the jungle every day for 40,000 years and collect what they're going to eat that day. And so they are the last indigenous peoples touched by colonialism in the West. 1994 was first contact. And so really unique opportunity to take a look into how did we eat and how did we survive and how did we actually thrive in a very balanced and a thriving fashion of relationship to our food systems historically. And interestingly, they practice a lot of the things that you all are starting to understand in this mission of regeneration. They understand the importance of not only collecting natural food sources, but also agricultural organization. And so each family organizes growing systems, and they cycle these growing systems every few years to different patches within the rainforest and come back to them after a period of time of rewilding. And so it's interesting that they aren't just hunter-gatherers at all, but they've actually had organized agriculture for tens of thousands of years in this space and have really developed a wonderful technique for bioresilience, understanding that they always triple their kind of backup plan. They've got 3 farms and 3 different microecosystems so that if there's flooding, if there's shifts in weather patterns over long periods of time, they have redundancy in their food system. So brilliant, complex understanding of food resiliency and independence that has emerged from the Achuar tribe over that 40,000 years of listening to nature. And we find ourselves at this critical moment in human history where we're going to have to do the same. If we don't start listening to natural systems as our metric, we're going to lose the miracle of human life. From a medical standpoint, we are really leading the charge in the United States for chronic disease and dysfunction within the human biology. For me, my journey into medicine began unexpectedly. I was actually going into engineering I had spent my years in automotive mechanics and construction before going into my higher education, and was good at working with my hands. I thought I would be engineering. Took a year off from my schooling and went over to the Philippines with a group of midwives and started birthing babies, just as a change in life, kind of opportunity to kind of broaden my vision. And I came back knowing I couldn't be an engineer. I needed to go into this field of medicine because the miracle of childbirth was so stunning. It made no sense on the engineering level how a system of 70 trillion human cells could come to organize themselves so perfectly within the womb of a woman within just that brief 9-month period to give forth the vitality of the infants that I was seeing born into really abject poverty and environments of starvation, all that. And yet these kids were born with this incredible drive for life, this incredible resilience at both the biologic and psychological, spiritual realms. And so that was really the intrigue that pushed me towards going into medicine. And it would be 25 years later that same awe of human existence would push me into your industry of farming. The reason that happened is because by the late 2000s, as we were moving into the second decade of our millennium, it became clear that we were at a tipping point of human biology and perhaps planetary biology, that we were reaching the sixth great extinction, and it was accelerating at an amazing rate. We are now losing about one species every 20 minutes. As we talk today, we'll lose 3 to 5 more species to extinction that will never come back into the human or planetary biologic systems. So the startling rate of extinction that is happening within us and around us is going to come sweep us up. We can track this by sperm counts. This is looking at the rate of decline with the launch of our large-scale chemical agriculture in the mid-1970s in the United States, 1974 being a real tipping point with the debut of Roundup as a broad-spectrum herbicide, which really translated into a massive acceleration in the scaling of farming. So from 1974 with that debut to just the next 40 years there in 2010-14, we had more than a 52% decline in sperm counts, not just in the United States, but throughout the Western world. And so the only place in the world right now that we see some stabilization of sperm counts is in Africa. As we start to reduce the amount of starvation there, we see some recovery there, but note that they were low to begin with. And so across the world, we see this rapid decline globally. The last 5 or 6 years not included on this graph that we have data for is pushing us to more like a 57% decline. So we're reaching a 60% decline. It's on this rate that we have seen no tapering off of yet. We could be infertile as a species within the next 40 to 60 years. And so that stunning result was actually mimicked in the science or paralleled by the science that we found on the farms when I started diving into agricultural systems in 2017, working with the Soil Health Academy and listening to one of their first lectures. I believe it was Ray Archuleta who was giving the talk. And Ray had a slide showing the decline in soil fertility globally. And the line actually maps out to an extinction of harvestable crops by 80 years. And so it was stunning to me that the human biology was mapping so closely to the harvest capacity of soil systems globally. This is kind of that incredible intersection now that we see between soil health and human health. We are doing something at a global scale that is decimating the planetary function. The revolution in science that's happened over the last decade in genetics has really blown apart the paradigm of what human health looks like. This is probably the biggest human science revolution that we've had in our collective memory. In the year 2,000 years ago, we saw Pythagoras and the Greeks discover that perhaps the earth wasn't flat, but was actually a sphere. That was such a radical change in our understanding of all science at that point. It even challenged psychospiritual kind of beliefs about how we functioned as a species, as a high organism. And then 1,600 years later, a telescope would be discovered, and we would see the sudden realization that the planet was not in the center of the universe. And this, again, not only challenged science, but spiritual identity. If we're not at the center of a vast universe and we're spinning through this vast universe as a tiny little speck of life, what does that mean for our identity? Why are we here? Who are we? What are we here to do? And now we find that same challenge, but on a whole different scale, because genetics has uncovered the fact that, like the planet not at the center of the universe, the human cell is not at the center of human health. And that revolution is pointing us to this new identity as human ecosystems rather than human beings. And that startling result is really being played out in the genetics. The human only has 20,000 genes. This is a miserably small number compared to what we thought we had. When we set out in the 1990s to decode the human genome, we were fully expecting to find 280 to 400,000 genes because we knew we had that sort of variety of proteins that were coming from the translation of genes into proteins. And we had been given that model by Watson and Crick, and all of the DNA scientists since had told us that one gene made one protein made human health happen. But with 20,000 genes, some 10x fewer or 20x fewer than we expected, it changed our understanding of genetics completely. To put it in perspective, a fruit fly has 13,000 genes, and the flea, that tiny little insect with a great jumping capacity, has 30,000 genes. So you sit somewhere between a flea and a fruit fly with your genetic complexity at that gene to protein translation level. And so this is challenging us to really understand that human genetics is not enough to live out a life that we have. How do we make these hundreds of thousands of proteins in our body that don't come from a straight gene product, or that from the human DNA? And the answer is really being uncovered within the genetics of the microbiome. And so the 40,000 species of bacteria that live in and around the human produce over 2 million genes. And those 2 million genes contribute massively to the protein function within your body. It's now estimated that more than 95% of the work done in a human body is done by an enzyme or protein structure produced by bacteria instead of human cells. To dwarf that one, we can look into the parasites. 300,000 species of parasites in and around the human experience produce 2 billion genes. And so we can again see these logarithmic leaps in genetic intelligence within the life around us and in us. The fungi continue to boggle the mind. The fungi at 3.5 million species is now considered to have over 125 trillion different genes within that genetic world. And so this is just this dumbfounding reality that biology in its diversity is really doing the work that would allow for human life to occur, which of course starts really changing our understanding of what does a healthcare system look like. We need to stop trying to sterilize human bodies through antibiotics and pounding back the germs, trying to wipe out all viruses and bacteria to sterilize our experience. That's been the dogma for almost 100 years in Western medicine and allopathic medicine at large. And so we need to stop that. We need to immediately kind of reorient through the last 20 years of genetics, proving that that was the wrong path. In our sterilization of our world, we're losing the genetic intelligence within our organism because we're losing the ecosystems that support life within us. If we now turn to the virome briefly, in this pandemic era that we're in, we've come to fear viruses on a global scale like never before. But if we take a look at what is really happening in these viruses, we find out that the viruses are what built us. More than 50% of the 20,000 genes you have were inserted into the mammalian genome by viruses. This whole fear of gain-of-function laboratories, that are happening at the military level and all of this throughout the military medical complex globally, pales in comparison to the gain-of-function capacity of life on Earth. Life is a process of gain-of-function. At every corner of human life and life on Earth, we've seen an explosion of adaptation and biodiversification on the planet. Even extinction events, like the last great extinction that happened 55 million years ago, forces a biodiversification, an increase in adaptive capacity of biology for the stress of extinction. And so as we put global pressure through our chemical toxicity and through our human extractive and destructive practices, we're putting stress on the planet that's forcing a rapid adaptation. The viruses are the method for adaptation. They are the language of the genetic code globally. And so we start putting out all kinds of new variants of genetics into the virome to try to find loopholes or workarounds to the toxicity that's causing the extinction event. And so in this, we're going to see continued explosion of viruses and their complexity, but they're never against us. They're actually trying to find the solution for life on the other side of humans. We are the existential threat to the planet right now. We are the catastrophic event happening to life and biology on the earth because we put ourselves in opposition to adaptation and biodiversity that would come from that. We, of course, in farming or medicine, have instead focused on monoculture. We've tried to scale for efficiency and monetary systems rather than scaling for life. This is where you guys need to, really become the frontier of life on Earth, is making this transition to understanding you at that critical level of the soil as really forging the path forward for a new humanity. You guys are really at that 0 point of where does life happen on Earth? It's not within the human cell. Life on Earth happens in the soil systems, the plant systems, the air that we breathe, the water we bathe in. That's the ecosystem environment that you guys are forming and shaping on this planet, and therefore there is no physician on the planet better positioned than you are to change the course of human history, to change the course of the survival of our species. It's not going to be the medical system that saves the world. It will be the farming industry and food systems industry at large. And so when we think about what you are and who you showed up to be right now, it's literally the most important thing that's happened in our history, not just as humanity, but the 97% of life that's going to disappear on Earth if we continue on the path we're currently on. You are here on purpose. I wanted you to really feel that. You are at this epicenter of food, life, vitality, our existence, our survival. This is what you're here to do. There is no more important thing that you do in the day than open your eyes and be willing to put your ingenuity and your hard work back into action again to create more life rather than more destruction and isolation of the human experience. Not only are we losing the genetics as we start to annihilate the microbiome through antibiotic use in the physician's office or through herbicide use in chemical farming, we're also losing the boundaries that create identity. This is our laboratory's efforts here. Our laboratory for the last 10 years has been focused on understanding what happens when we eliminate microbial intelligence, microbial communication at the human cell level. And so what happens here is we expose the gut membrane to glyphosate at about the concentration you would see in cruciferous vegetables or potatoes that are grown in conventional systems, in that 2 to 20 parts per million of glyphosate, and it blows apart the gut membrane. It blows it apart by damaging the tight junction, which is the Velcro that holds the cells together. So on the left, you see a baseline small intestine. On the right, you see that just 16 minutes after exposure to Roundup. And so with just trace levels of Roundup in our food system, we go on to create direct damage to the gut membrane, which blows apart the boundary event that separates the microbial soil intelligence of the gut to our immune system. As you lose this barrier system, every bite of food, every minute that you're awake, your immune system is in conflict with that greater environment because you lost the boundary. You have become a leaky sieve to the world outside, and the human body is being inundated by too much biologic activity, too much force of reactivity. And so you are in a constant food fight. You're in a constant war of the immune system against the environment because the walls have been breached. And so as we start to study chemical farming, we have to come to terms with the fact that these chemical residues that we are putting into the soils to kill everything from weeds down to the pests that our pesticides would address, we're going to do the same thing to our gut. We cannot get away from the antimicrobial, anti-life kind of effect of 2,4-D, dicamba, Liberty Link, Roundup, whatever combination you're now using, the nicotinamides. These compounds that are designed to kill life continue to kill it within our own bodies, and therefore leaving us vulnerable to the loss of self-identity. That loss of self-identity by the boundaries falling apart, we no longer know what's outside and what's inside, is the foundation of chronic disease, whether we're talking about autoimmunity, neurologic dysfunction, or cancer. That leaky gut phenomenon, unfortunately, does not stop there. So glyphosate damaging those tight junctions, as those barrier systems fall apart, you start to get passage of information or compounds that are unregulated. And so the toxin effect, opening that up, you overwhelm that immune system. This is how we developed widespread gluten sensitivity globally in the 1990s. We went to genetically modified Roundup Ready foods that for the first time left high amounts of residues of glyphosate in our corn, soybean, wheat, etc. And as that tight junction fell apart, the gluten compound gliadin, which is the large protein that holds gluten in it, would transit the gut lining without protection, and the immune system would have to react. And so we all developed some degree of gluten sensitivity, and of course had an explosion of the autoimmune disease celiac, which destroys the lining of the gut and its ability to absorb nutrients globally. And so we created that through this incredible poisoning of the gut through these trace levels of glyphosate and other herbicides in the mix. So we lose the genetics, we lose the barrier of identity, but then even deeper than that, from my standpoint, is we lose the ability for energy production. Energy on this planet is entirely a story of carbon. The energy of the sun is radiating through our atmosphere, creating an incredible thermal event, certainly warming us every day, but it's also creating an opportunity for fuel to be generated within our crop systems, within the plants of the earth, whether it be the rainforest of the Achuar tribe or your corn soybean mixes out there in your fields. It's being captured by the plant plastids. These are mitochondria, little bacterium that live inside of the plant cells, and these little bacterium that are called plastids live packed inside of the plant cell to create the energy within our food. Chlorophyll is the most famous of these compounds. The chloroplast, little plastid, absorbs the sun energy and combines CO2 into long chains of carbon as a battery storage. And so it can make complex carbohydrates, it can make fatty acids, and by capturing that light energy, it can then pass that to biologic systems. And so the bacterium within the plant, called plastids, is building the carbon energy system, and then the plastids within the human cells that we call mitochondria are breaking that back down. And so the mitochondria within the human cell starts to break down the long chains of carbon that would be carbohydrates or fatty acids. And in breaking the carbons apart, it releases the sun energy, the electrical energy, back into your body to vitalize human biology, to vitalize life itself. And so in a beautiful way, the microbial diversity within that we call plant plastids or mitochondria within us is literally the most efficient energy mechanism that has ever been created within our known world. And so it's very interesting to start to think about farming on this scale. What are we doing in farming that undermines the chloroplast health and vitality within plants? As we undermine that, not just the plastid, but not just the chloroplast, but the other plastids that would make the alkaloids and a lot of the other medicines within our food, we start to lose the nutrient density within our food chain. This, of course, leads to weakened plants, which leads to poor root system communication, which then opens up the avenue for invasive weeds and other overwhelm to the plant's immune system, leading to more herbicide, more pesticide, all of these usages to try to stabilize or palliate an increasingly weakened system of plant life on Earth. At the same time, the cattle, the poultry, or the human that's consuming those nutrient depleted, energy depleted plants are finding the same poison that is killing the plastids within the so we lose mitochondrial density every time we consume herbicides. And as you lose mitochondrial density, you lose the ability to liberate energy from your food system. And in the same way, you lose the energy to release that electrical charge of the sun. And so our ability to thrive on the planet, and that we can see in every ecosystem on the planet, and every people's on the planet right now, diminishing our health because we literally have less energy to work with. So these are the three mechanisms by which agricultural practices are really devastating human health. Number one, it goes and undermines genomics of the soil, plants, and the life around us, the soil, water, and air systems. With less genetics and higher stress levels, we force adaptation through the virome, and we're trying to find our loop out. So genetic challenge. Number two, we lose barrier systems. For the loss of microbial intelligence and communication, we lose the ability to repair the proteins of the tight junctions and the like, and therefore become vulnerable to that constant overwhelm to the immune system. Chronic inflammation occurs. Number three, we lose energetics. We lose the energy production within the body. What this then immediately translates into is the exact events we've seen globally around health. This is looking at kind of some of the top most prevalent conditions out there. Sadly, this includes autism in the Western world. We now have 1 in 36 children with autism, and the curve at which this is increasing is terrifying. So in 1975 in the US, we had 1 in 5,000 children with autism. By 2012, that had increased to 1 in 88. And there was a lot of discussion in my industry, well, maybe we're just recognizing this condition and therefore we're overdiagnosing it, or we're diagnosing it for the first time, therefore it looks like an epidemic. So we redefined in 2012 all of our diagnostic criteria to try to normalize it, to make sure there wasn't some sort of diagnostic bias or error in this data. Over the next few years after that, we would see this incredible explosion of autism increase. And so we went vertical between 2012 and 2015. We doubled our rates in just 3 years to 1 in 44. And that march continues. We are now somewhere, 1 in 36 was 2018 data. We're probably looking today, even though the US takes forever and COVID completely distracted us from any good public health metrics on this, but we're considered probably somewhere in the 1 to 24 children with an autism spectrum disorder now in the United States. We are now on track to hit 1 in 3 children with an autism spectrum disorder, attention sensory processing defect by 2035. So within the next 14 years, we could see this rate of 1 in 3 children with a neurologic deficiency in sensory processing. Attention deficit, of course, is way more common than autism spectrum. In the United States, we're at 1 in 10 children. Stunningly, 70% of these kids are already medicated by the time they're in middle school, which would be around age 12. So by age 12, we've got 70% of these kids on some sort of stimulant medication that is similar to adrenaline. And when you put kids on Adderall or Ritalin or these adrenaline drugs, you take away the part of the brain, you shut down the part of the brain responsible for creativity. So we're raising a whole generation of children that are largely medicated to shut down their capacity for creative thought. This is terrifying because at the brink of all things, at the brink of human health and our civilization, we need the most creative thinkers in the universe. We need to have the most ingenuity brought to bear than we've ever had in the past, at a faster rate of change than we've ever seen. So we need to unleash human creativity if we are to survive. So we need to quickly rethink the way we're certainly dealing with that. But as we pour down through this, you see again the 3 effects of energetics being at the base. And so as you get more and more common here, you're getting down into diabetes and obesity. 1 in 4 adults in the United States with diabetes or prediabetes, obesity now at 1 in 3 adults. This is looking directly at that metabolic collapse of the mitochondria. So as we lose the ability to liberate nutrients from our food, we store fat. We can't break that fat down into light energy, and so we have no choice but to store the fat. And so everything from the aspartame in our diet all the way to the glyphosate and all of this, these chemicals are undermining that energetic capacity to translate food nutrient and calories into light energy, and therefore we become obese. We get fatty liver, diabetes, and obesity. The brain continues to suffer major depression now at 1 in 3, and we see this at the highest rates actually in our Western farmers. Chemical agriculture has had a devastating effect on mental health. I've spent a lot of time on farms throughout the Midwest, and not only do we have major depression, we have generalized anxiety disorders. Almost 100% of our farming community have severe sleep dysfunction. With that sleep dysfunction, we have immune dysfunction, and ultimately we have cancer. And so we have now 50% of American adults, American adult men with cancer before they die. And so 50% prevalence of cancer in this country is a mind-blowing number because it never looked like that before. But here's how that correlates with the spraying of glyphosate compounds in our country. Starting in the early 1990s, you start to see the red lines climbing here. This is glyphosate applied to corn and soybean per 1,000 tons. And so this steady climb throughout these decades shows this huge explosion of myeloid leukemia going on throughout the country. At the same rate, you see urinary and bladder cancer, which is important because bladder cancers are the harbinger of toxins in the environment. If you pour a toxin in the environment, you're going to see explosion of bladder cancer. So this is direct toxin evidence here, looking at bladder cancer and herbicide uses with glyphosate. You can see the same phenomenon with thyroid cancer. The thyroid gland is the most vascular of all the endocrine tissue. You get about 25% of your blood volume goes through your thyroid gland every 5 minutes. It's an incredible exposure to blood compounds, and you see thyroid cancer going up at this steady rate, almost perfect linear with the use of glyphosate in our environment. Liver cancer, liver is really the filtration system, the detox system of the human body. And so it takes the highest load of toxins of any other organ system. And so not surprisingly, we see liver dysfunction and cancer of the liver increasing steadily with the increase of herbicide usage in the United States. This is looking at senile dementias, both Parkinson's and Alzheimer's dementias, again mapping perfectly with our glyphosate usage in the United States. This is looking at just sleep disorders. As mentioned, all of our farmers are having sleep disorders in the United States that due to chemical exposure, really. But this is looking at the entire population and its perfect correlation with glyphosate in the environment versus sleep quality. Sadly, this is what that system of disease has built. This is Texas MD Anderson Children's Hospital. MD Anderson is the largest cancer center in the country. And when we start building full cities at the kind of wealth that you see pouring into these beautiful buildings, you get a sense of the scale of this industry of disease management. We call it healthcare in the United States, but it is not. It is disease management. We are now spending $3.8 trillion a year in the United States on disease management. And unfortunately, our children's hospitals, which are all of these towers, by the way, you see the front tower and the four behind it. Every one of these towers has had to expand to handle the amount of children with cancer in this country. If you put that in comparison with our military and defense budget, we only spend $0.7 billion per year on that. And so we are 5x the spending on military defense in our healthcare system. It is the largest moneymaker. It is the largest economic driver in the United States. And our GDP and our fiscal balance, our fiscal solubility as a nation is dependent on our disease management now, which is a vicious trap. We just printed $4 trillion, through just arbitrary quantitative easing here in response to this pandemic. We printed $4 trillion because it was the only way to boost up a complete economic collapse that's undermining and increasing the fragility of the U.S. dollar. And so we have a very toxic and frightening phenomenon in the United States where we have to have disease to be able to continue to generate money through the healthcare system to stabilize our economy. That's a vicious cycle that we can't tolerate any much longer. So how does this correlate really, all this disease, with the patterns of disease and glyphosate exposure? On the left, you see cancer maps in the United States between 1970 and 1994. This is looking at colon cancer, lung cancer, prostate cancer, and for all of our cancers, they've always been concentrated in the Northeast, with the exception of prostate cancer, that was both the Northeast and the Northwest. But never in our history as a country did we have an epicenter of cancer in the South. But in 1996, we debuted widespread genetically modified organisms, Roundup Ready crops throughout the United States Midwest. And over the next 10 years, we flipped our cancer map. So suddenly on the right, you see a complete reversal of our historic cancer map to this huge epicenter of cancer in the South. And so when I saw this map and realized we had flipped it, I knew that we had done something to our soil and water systems that was something equivalent to Chernobyl. You have to have a nuclear event to create this kind of impact on cancer incidence in a diverse population. So we created a nuclear event, something in our system that completely flipped this map in a 10-year period. When I found the glyphosate in our work in our laboratory in 2010 to be at this kind of fundamental undermining of the microbiome and genomics of human health and the energetics of human health, we started to look at this as the potential epicenter for this cancer change. So this is looking at glyphosate spraying. In 1992, it was being spot sprayed as a weed killer, but could not be applied to crops, obviously, because it would kill them. In 1992, we started to spray it on wheat as a desiccant. And so we started that widespread usage. Actually, I believe the first usage of glyphosate was in Ireland as a desiccant in 1991, 1992. And that then spread to the United States as an important practice of accelerating the drying of wheat towards the end of its life cycle to accelerate harvest rates. And with that practice, we began applying this chemical straight to our food. Gluten sensitivity occurred as soon as we started applying glyphosate straight to the wheat shortly before its harvesting. By 1996, we were spraying in all of, much of our Midwest, and by 2011, it had taken over 95% of our corn and, soybean and 85% of our corn industry. And with that, we saw that explosion of usage. We're using 300 million pounds of glyphosate annually in the United States, about 4 billion pounds throughout the world now. This is the map that really changed the way I was looking at things. This is a map I found of the river tributary systems throughout the United States, and this huge pink swath throughout the middle is the largest river system in North America. It's the Mississippi River tributary system. The Mississippi River, it turns out, ends in Louisiana, and so the last 90 miles of the Mississippi runs between Baton Rouge and New Orleans in Louisiana in our deep south, And that is now called Cancer Alley, the highest rates of cancer in the entire developed world. And so we created a glyphosate collection system of this water-soluble herbicide that was capturing some 80% of all of the Roundup sprayed throughout our Midwest and the northern agricultural system, and putting that into a single water system, concentrated that, and caused devastation, not just in human health, but also of planetary health. So this is a satellite image looking at oxygen vitality and carbon cycling and water systems. And you can see the dead zone that's developed at the end of the Mississippi River. The dead zone is now larger than our state of Rhode Island. The threatened zone is larger than our state of Texas. It is hundreds of thousands of miles of damaged ocean. This is what dead ocean looks like. On the left, you see the dysfunction of biology happening. On the right, you see the clear waters of microbial diversity. But as we undermine microbial diversity through herbicides and then pour nitrogen in there, there's only a few algae that can bloom in that environment to try to clean up the mess. The algae are not toxins. The algae are not trying to destroy the environment, which they're often blamed for. They're actually trying to clean up the chemical mess that's in there and try to bring balance back to nitrogen and carbon systems within the water. And so we are really devastating the system. This is actually the Mississippi River itself blooming with algae now. And so we really are losing biologic stability throughout our freshwater and ocean waters throughout this agricultural system. Not unlike the human system that's buried in antibiotics all the time and therefore denuding us from our microbial diversity, our agricultural systems have done the same. If you look at native grasslands or any biologic system of life on Earth, you see not only biodiversity, but you see complete coverage of the ground. In our agricultural system, we see huge swaths, the vast majority of soil systems constantly exposed to the environment, no protection. So you guys are well versed, I'm sure, in the importance of getting soil covered. Soil has to be protected from the elements, most of all perhaps sun, but also rain systems, so that you decrease silting and wash off of that critical topsoil. And so in the same way, we see this same management practice being done in the winter. Wintertime, the fallow ground under native grasslands is one of the most important times of reabsorption of nutrients that will then lead to the explosion of life in the spring. But in the United States and many other Western chemical agricultural environments, we completely denude the ground during the winter months, and we feel that a clean field is the best proof of good farming management. So we've gone to completely denuding that land of any nutrient that would be reabsorbed over the wintertime, and we lose vitality in the soil. As you know, the macro systems of life, like the earthworms, the nematodes, and the rest, are critically tracking that of the microbiomes. As we start using herbicides broadly as we do, we lose the density of macro life as the earthworms. Studies in the United States here show that one spraying of glyphosate across a field at the beginning of the year for killing back cover crops or killing back weed growth is enough to kill 100% of the top dwelling earthworms and their fertility, and about 50% of the deeper earthworms with that single treatment. With continued treatment over 3 to 5 years, you lose all of the earthworms in that system, obviously. And so we go from this nice structured ground or soil system that you would find in a regenerative or natural environment to what we see throughout, not just the United States, but all agricultural systems really worldwide, is dirt. We have lost the architecture of soil, we've lost the mycelial network, we've lost the mycorrhizal intelligence, and we go to unstructured dirt that is not capable of moving nutrients into the root fibrils of life and our plant life. Globally, of course, we've got about 97% of soil systems degraded or severely degraded. And so we have very little stable soil left on Earth. It is predominantly located in the tundra above Russia or above Canada and or in our mountain systems. And so it's 97% of our arable lands, farmable lands, we're looking at severe or degraded soils. As we do that, we lose the carbon cycle. As we destroy that soil structure, we lose the ability to absorb nutrients from the air back into our soil systems, and we lead to a concentration of carbon compounds like CO2, methane, and the rest of the atmosphere. We've gotten the climate change kind of global warming story, I believe, backwards. We keep blaming the CO2 in the atmosphere as if that's causing global warming. The thing that's causing global warming from my perspective is obviously the dead soil underneath our feet that can no longer breathe that CO2 in. We're dying for a lack of soil and plant vitality, not for CO2 in the atmosphere. CO2 in the atmosphere is where it's supposed to be. That is its easiest location to be reabsorbed into the carbon cycle. We broke the carbon cycle, therefore we broke the energy cycle of the planet by killing the soil beneath our feet. The amount of loss is pretty stunning, by the way. In the United States, we're losing about 2 tons or 4,000 pounds of soil every year per acre. This equates to about 11% of our $17 trillion GDP being lost in natural resources every year through poor soil management. And so it's a devastating effect on long-term stability of economies and resiliency and resources within nation states as we continue to do this conventional agricultural. As mentioned, the loss of carbon cycling, we really are undermining the ability for life to occur on the planet. That's why extinction is happening across all species, is there is no longer the ability to create vitality within the nutrient food systems for plants, animals, or humans. And so with the loss of vitality of the soils, with the loss of the vitality of the plants that would be converting sun to energy, we have a loss of life on Earth and the 6th great extinction underway. The good news on farms and humans, and this is kind of where I pause and pivot to the fact that there is great hope. I have not lost hope for humanity or our future. I believe that there is a very bright future ahead, but it's going to have to be re-envisioned immediately. All of us in this group that you're in today are going to have to be such a force of shift, such a transformational energy, that we can do this within a matter of mere decade or two. If we don't beat that kind of 1 to 2 decade kind of impending doom, we may be too late and we may march into our own extinction, which may not be a bad thing for life in general. It will be perhaps a missed opportunity for humanity as we move past life as we know it. But certainly we know that the planet is built on a biology of resilience. The planet will definitely recover from humans. It may take a couple of a million years, maybe tens of millions of years, as it did following the last great extinction event, which, by the way, was due to a death of topsoil. An asteroid hit, covered the Earth in a layer of dust that choked out the microbiome of topsoils, and we lost about 90%, 95% of life on Earth with that last great extinction. It only took 20, 30 million years for life to not only return, but life to return even more abundant and with a higher intelligence, because more genetic adaptation had been placed into the atmosphere, into our soil, water, and air systems than had ever occurred before. So when life came back, it came back not with ferns and dinosaurs, it came back with deciduous trees, flowering plants, fruits and vegetables. It came back with mammals and ultimately humans. That intelligence that left from ferns to that kind of deciduous environment of life, from egg reptiles and avian birds, to leap to a live birth mammal, was an enormous innovation of life on Earth occurring through the virome, through this new genetic intelligence on the planet. And so in the hope of my heart is life will return, and a knowingness within me is it will return more beautiful, vibrant, and intelligent than ever before. And the selfish part of me says, I want to stay and play with that. I want you to stay and play. I want your grandkids to be living on an Earth that is more vibrant and biodiverse than ever before. And that's where I know we can get to, because we see it in your transition to regenerative agriculture just in a single season. We stop spraying and we stop over-tilling, and we start into a process of biodiversification at every stage of farming, from our soil management to our cover crop management to our soil disruption systems, to our biodiversification of macro life on top of that, whether it be agricultural use of animals or the roller crimpers or whatever you're using to start accelerating that carbon and microbial cycle of life and regeneration within those soil systems. We see a vibrancy return to these farms within a single year, but then you move out 3-5 years, a short window, and you're seeing that farm thrive. A farm that was nearly bankrupt, about to lose a multi-generational farm, is now actually becoming so resilient that it's resistant to flood and drought damage. It's resistant to the climate shifts that we're seeing around it, and it's the only farm surviving within hundreds of miles around it in this adversity of environment. It's becoming independent. It's becoming resilient and adaptive again, because the microbes are becoming diverse. With diversity comes adaptation. With adaptation comes a reinforcement of biodiversity. And so it's a positive feedback loop that occurs. In our laboratory, we demonstrate that through the ability of bacteria to not just make the typical nutrients that we think of from the gut, but we actually have been studying these small carbon molecules made by bacteria, fungi, and the like that lead to the functional communication between systems. We call them carbon snowflakes because each bacteria and fungal species makes 10 to 15 variants of these, so we call them carbon snowflakes. And those carbon snowflakes work together to create a seamless communication network. Picture it like a wireless network of communication from your cell phone towers connecting each phone together so that there's a greater intelligence capable. When the cell phone tower goes down, all the cell phones still function. They still have all of the mechanics within them to work, but they are disconnected. And for that, they can't update their software. They can't update the calendars. You don't know to meet grandma for lunch, and you miss your opportunity for a community, and you start to become isolated. In the same way as the cell towers go down, as the microbial diversity goes down in biologic systems, whether it be soil or gut of a human, we see the collapse of communication, therefore isolation happening at the human cell. And it turns out that isolation at the cellular level, be it a single human isolated from its social environment or a single cell isolated from its social environment of the greater organism, we see cancer develop. In the human, that looks like major depression and suicide, homicidal things, more extractive, more destructive, more instability of that organism. At the cellular level, that looks like autoimmune disease and cancer. And so from the micro to macro, isolation is the meta disease. And so we need to overcome that by supporting microbial life. And excitingly, as soon as microbial intelligence is put back into the system, you start to get biodiversity. The cell phone towers go back on, and it starts to coordinate macro and micro life regeneration. And this resilience is seen within minutes in our laboratory. And so in the end, as we start to think about the future of food systems, we need to not just go by and look at neighbors' farms to understand this. I really encourage each of you to go out into the deeper nature, go find a deeper system of nature around you, and just sit and listen. There's so much information for your body to absorb in a natural environment. And I want you to start to think about what would your farm look like if it was to embrace this sort of biodiverse systems? What would it feel like if the ion charge in the air around you was as intense on your farm as it is near a waterfall or a beach? That is possible. We are capable, and we have the ingenious nature of farmers themselves at our opportunity. You guys are really at this epicenter as stakeholders in the food system to fundamentally change the way we think about human life. And it's going to be at each point focused on our capacity for adaptation and our embrace of biodiversification. Instead of extractive, consumptive beings, we could shift honestly into this extraordinary state of co-creator. We can co-create on this earth with a nature that's calling us into harmony, calling us back into coherence with her patterns of life. And if we step back into that, we could avert our own extinction and really start to embrace an explosion of life within our children that would prove not only to support their thrive state, but really to protect the future of our species. I want to open that up to questions as soon as possible, but I think we might take a break before that, but I'll turn that over to you all to reflect back at me where we're at.
Wow, there is so much to take on there. I don't even know where to start, which is exactly the reason, I suppose, for taking a small comfort break now. Comfort break, that's a diplomatic way of saying go to the toilet, or maybe even go to the fruit bowl, find a fruit fly and contemplate how much more impressive you are than it, but just stay away from the fleas if you don't want to feel insignificant. We'll be back with Dr. Zach Bush in about 10 minutes or so. Talk to you then. Now, Zach, you have to, frankly, treat us delicately and help us put together some semblance of a rational world around us again, please, after your presentation. Can I play devil's advocate for a minute on the glyphosate stuff?
I hope you would.
Good, because some of your graphs could reasonably enough be construed as being examples of correlation rather than causation, because to my very, very imperfect knowledge of this, there is no really firm links between background environmental level glyphosate exposure and those increase in cancer figures. Or is there? Please tell us.
Yeah, there's actually a lot of science around that. My background is a chemotherapy developer at the University of Virginia. I was developing chemotherapy, so I became very familiar with how to measure cancer changes within cells, especially within the mitochondria. And we can measure down to parts per billion of glyphosate to show those effects on mitochondria and the upstream effects on protein synthesis and the like. So
specifically on glyphosate, Zach, or were there other chemicals in the background environment again? I mean, I'm thinking of some of the earlier generation of agrochemicals like lindane and so on that were banned a long time ago but could still be present. I mean, why blame everything on glyphosate when there's so many other chemicals out there?
Yeah, interestingly, glyphosate's the tip of the spear, I think, just because it's the most prevalent chemical in the environment, and it's the gatekeeper, as I would call it, because of its effect on tight junctions. So it directly poisons the tight junction, breaking down that barrier system in a root fibril or in the human gut. So the root system of the gut looks a lot like the root system and the root fibrils on a plant. And so the glyphosate kind of opens up the gate, and so now there's a lack of barrier for your 2,4-D, your nicotinamides, all the other residues, you're right, of things like DDT from 50 years ago that are still in the environment, and we see the genetic complications from those. So I think it's the combination of many chemical factors, and so it just so happens that glyphosate is the only one that maps kind of perfectly to these trigger points in biology. In 1976, we see the tipping point into the virome. We've had 12,000 pandemic viruses since then. Right at that point, this massive pressure with the advent of the chemical. Then we see 1996 with that. So glyphosate measures out at the public health level better than any other introduction of a single chemical. But I believe it's only the beginning of the toxicity. And we know that Roundup as a total is far more toxic in our laboratory than glyphosate. All the data we shared with you today and have with the world, we show with pure glyphosate initially, no other surfactants, no other chemicals in the mix, to show direct influence on that tight junction system and ultimately the phenotype development of cancer. So we can show that in the laboratory over the course of 7 days easily, but even in the first 24 hours, you can see the transition from tight junctions in proximal renal tubules or gut, and as those tight junctions blow apart, then you get the phenotypic changes towards cancer. So we know that glyphosate does that alone in the laboratory, whereas if you put 2,4-D or others, it's indirect effects on downstream risks of human collapse of function or disease occurrence. So glyphosate seems to be this kind of harbinger of toxicity and is not singular. So it is a correlation in the sense that it's not the single insult, but it does have direct injury that we can map to the carcinogenic process.
You had another very alarming image showing cellular breakdown at between 2 and 20 parts per million of exposure to glyphosate. What does that level of exposure relate to? A farm worker or somebody who's eating cruciate vegetables that have been grown in glyphosate-treated soil?
Yeah, so that's the consumer. So your beet and your radishes, things like that are grown in the U.S. and soil systems are good examples. Kale and some of the cruciferous vegetables above the soil, but your root vegetables, like your beet, are easily in that 2 parts per billion, or I'm sorry, 2 parts per million levels. So this is consumer level exposure. Your farmer can obviously have much higher residues, but the farmer, as you know, in this system, at least in the United States, we have them in full hazmat suits, respirators, everything else, because of the known toxicity of these chemicals. And so the farmer, depending on their exposure in the field, it may not be the field element that's really doing it. Many of the farmers throughout the Midwest that we visit have to keep their children indoors throughout the growing season because there's so much airborne, 2,4-D and glyphosate in our environment. 2,4-D has become a real, dependency, and dicamba as well, but 2,4-D I think is probably number 2 right now. Atrazine is back in the system in high volumes too, because we have so much glyphosate-resistant weeds in the United States due to overuse of this chemical herbicides. The plants always figure out the genetic loops, right? The gene that goes to create Roundup-ready corn isn't ever stable in the corn. It's mobile. All genetics are mobile through the virome. And so we can pass those traits of genetic resilience in the face of glyphosate to the weeds, and then they do horizontal gene transfer throughout the mycelial bed to get that through. So throughout 9 of our states in the Midwest, we have, the dominant weeds are all glyphosate resistant. So 2,4-D and atrazine have become major dependencies again. And so glyphosate's far from the only chemical toxin that we are exposed to as farmers or as consumers. But we've worked hard to demonstrate that glyphosate is really lining up with these public health events more closely than any of the other chemical introductions.
One last quickie question of my own before we start going to audience questions. If sperm counts have dropped so dramatically, 60%, how come the population is increasing equally dramatically in the opposite direction?
It is decreasing in Western world. So where we see growth of it is still in sub-Saharan Africa, is where we see most of the population growth, as well as some of the developing world. So if you eliminate the developing world from population growth, you see retraction throughout much of Europe. You see retraction in the United States. You see retraction in China of fertility rates, and so we're seeing that decline. China has completely reversed their whole position. You remember the one child rule that they imposed on their population. They removed that 10 years ago, and now have public incentives for people to try to have children right now, because they have such a dangerous reduction in fertility rates right now. So it's not just the West, but also the East there, with China becoming the largest producer of glyphosate globally now is China. The heaviest concentrations of glyphosate usage in the world, and especially in our exposure to our meat industry, is Wuhan province, where the current pandemic began. So where we see the highest levels of biologic stress on the planet are perfectly mapped to glyphosate usage in our agricultural systems.
Let's go to audience questions, which you can still contribute, please, by using the button over there on the right-hand side of your screen. Karen Mahan would like to know, the Shuar and Ashwar tribes have staple manioc diet with fruit foraging and carne de monte, wild meat and fish. Did you see any prevalent disease typology there?
Yeah, you can see it. Where you see it is in their children that are being shipped out of the Amazon now to go to school in Quito or other developed cities within Ecuador and Peru, and they immediately get prediabetes. I met a lot of their leadership who are suffering from obesity and diabetes because they are on the road a lot. So as soon as they leave the jungle, they almost immediately develop fatty liver and diabetes and obesity. I'm actually working with one of their leadership now who's had to drop out of leadership so that he could stay in the jungle and eat his manioc and traditional foods again, which aren't foraged for. They really do have an intelligent and very complex agricultural system of growing these things through organized systems of agriculture. But as soon as he moved back in with his family and stopped leaving the jungle for Western civilization food system exposure, he lost 120 pounds. He's back to his normal body weight. His diabetes is gone, but he's left with a horrible neuropathy that I'm now trying to treat through supplementation and everything else. And so as soon as they're exposed to Western, and we see this throughout indigenous peoples globally, certainly African American populations within the United States are a great example of this. So are Hispanic and other Central American populations. Certainly First Nations people here, our indigenous tribes within North America, were hammered by the toxicity. And so the genetics of the Northern European seem to be more resilient than a lot of our indigenous genetics to some of these injuries and the decline in energetics around the mitochondrial damage.
Which leads nicely into PJ Dooley's question. He would like to know, how does exposure to all of these man-made chemicals end up impacting on our microbiome? Yeah, great. I'm sorry I didn't drive that home better. I should have stopped to explain that, so I'm super grateful for this question. So the herbicide glyphosate is a potent antibiotic. It's been patented as an antibiotic, antifungal, antiparasite. It kills microbes within the soil system. And when we consume residue within our food system or water system, water is a big exposure. In the United States, 75% of our rainfall is contaminated with glyphosate. 75% of our air we breathe is contaminated with measurable glyphosate. And so we're breathing it, we're eating it, we're drinking it. Our river and systems are just decimated. Some 60% of rivers and 80% of the reservoirs in Indiana, for example, which is kind of middle of that epicenter of glyphosate exposure, are now considered not safe for recreational use. And so that recreational use means not only is it not potable, you're not supposed to touch it, you can't swim in it, etc. So that's 80% of the freshwater bodies and 60% of the rivers that contaminated. So we're seeing in real time this antimicrobial effect of glyphosate. It undermines the vitality of bacteria, fungi, parasites, and the macro life within it. So glyphosate at 4 billion pounds or 2 billion kilograms per year globally
is by far, in a way, the most abundant antimicrobial on the planet now. And so that's really how it's undermining life on Earth. It's not through direct damage to tight junctions, but as functioning as an antimicrobial.
Ian Gold would like to know, once the damage has been done to the gut lining and then to your general health, can this be undone through diet or lifestyle alone?
Yeah, there's a recovery process there, both for soil and human systems. And so as soon as you re-engage, so it's important not to do monoculture, right? And so when you try to recover a crop system, you can't go in with an alfalfa cover crop and expect that to be enough over a 7-year period to recover things. It'll improve things, but not recover to resiliency, because you're not really inducing biodiversity. You get a 15 seeds, 30 seeds, variety of cover crop in there, and it's just bonkers how fast the biology can recover. And so in the same way, we've got to think about biodiversity within the human gut. We have to stop doing probiotics. Probiotics are 3 species, 7 species at massive quantities, and the human microbiome is supposed to be somewhere in the 20 to 40,000 species. And so if we keep overwhelming that 20,000 species with the same 3 species at billions of copies, we plant a monocrop in our gut. And so really at each stage, we need to get away from the concept of micromanaging biodiversity at the microbial level and really opening it up to letting nature repopulate with its force towards bionature. So what we do in humans is expose them to as many ecosystems as possible. So I'll have them go to the high desert for a week, and then go to the ocean for a week, go into a deep forest or rainforest type environment for a week, and breathe as much of that in and touch as many surfaces. So they're literally, I have them running their hands underneath ferns. I have them digging in soil systems. We have to get our body covered back with as many ecosystems as possible. And if we do that, we can show immediate genetic recovery of biodiversity.
Which is a much more appealing way, frankly, of doing the same thing as I would imagine fecal transplant therapy. You don't favor that?
Well, it's a Band-Aid, right? So fecal transplant lasts for about 3 weeks because you've taken an individual who's in an environment that's destroyed their ecosystem. You give a transplant of a healthy ecosystem, it lasts for about 3 weeks because that person's still in the same ecosystem environment that killed the microbiome in the first place. Okay. So it's very short-lived. So if you've got somebody with an acute cancer or something like that, you need to slap a Band-Aid on it. Fecal transplant has a role.
But is a 1-week holiday in the Amazon not equally short-lived? Does it, once you return home, is the good not undone?
Yes, it is undone over time. If you return to your environment of antibiotics and eating glyphosate and rain exposure, everything else, you have to reinforce that environment. So, our group has been working on soil supplements to bring back into human and animal agriculture, and so we use soil extracts from 60 million years ago and extract the carbon communication network out of that, and we give that as a dietary supplement to animals or humans to give them that resiliency as a mechanism of finding their way back to biodiversity. But even that isn't enough to say, how do you get the bacteria back? You've got to get back out in the environment, which means we need a different lifestyle. We need to change the way homes, schools, prisons, all of these things work. Most of all, perhaps hospitals. Hospitals should be based and decentralized in agricultural systems, right? In the middle of a vibrant, permaculture, biodynamic farm should be tent-like hospital recovery beds for people to breathe and eat and be exposed to bionutrients and the biodiversity around them. That would be, that would be the most evidence-based, healthy place to recover on the planet if we were to start to move towards the evidence that's really there. The evidence is, by and way, ridiculous that the worst place to be right now is in an ICU, sterilized, away from all of nature. Your death is confirmed there.
It would be really nice if you could give us some hope in this answer, but I suspect you're not going to be able to. Michael O'Shea's question is there any evidence that the Department of Agriculture in the United States is shifting from the status quo to a soil-first policy?
Yeah, we're making baby steps towards it, and so I will give you hope. The hope is that stakeholders in the food industry are coming together outside of the regulatory environment, and that's what we have to do. Regulatory environments are never going to be the solution because they're not scientists, they're not farmers, they're not agronomists, and so we need education reform. But to do that, we're going to have to really come together as stakeholders and agree that we're on a common path. And I see that happening. The largest food companies in the world and the largest growers in the world are now coming at our nonprofit, which is Farmers Footprint, and asking us to be at the epicenter of communication. And so we're creating safe spaces for stakeholders to talk, because historically there's been a lot of finger pointing and damning, like it's your fault, it's your fault. We have to have verticalization of the food system around regenerative practices. And what I mean by that is we need to decentralize not just the ways in which we do soil management. We need to decentralize transportation, storage, distribution, all of these elements within the agricultural system to allow for regenerative practices to reach a consumer product or the consumer directly. And so to do that, we need all the stakeholders in the room. We need to stop pointing fingers. It's not about growers. Growers would like to change. They're happy to change. But to do that, they're going to have to be in direct relationship to either that CPG company, the consumer product goods company, or to the consumer. And to do that, we need to create environments of marketing and business development and kind of autonomy at the transportation and distribution system. So bringing stakeholders together is the answer. Certainly communication is always the key to success. And we're finding that the nonprofit space is allowing for this safe space for those communications to happen. For a large scale, Kellogg's or Nestle to come to the table, they need a safe space where nobody's damning them, telling them they're killing the world. We need to come to terms with the fact that the food system as a whole, us as consumers outsourcing food system to these companies, we stopped growing food in our backyards. Therefore, we created the demand for chemical agriculture at scale. We needed to take back that responsibility at the individual level. And I'm seeing that happen. Consumers are committing to it. Consumers are growing more gardens in the last year than they have in the previous 20 years in the United States. We're seeing this real change. Unfortunately, the pandemic was one of those aha moments. Not only did it expose the vulnerability of global supply chains for food and hospital equipment for that matter, but not only did we expose the vulnerabilities created by centralization of these economies, we also proved the importance of food resilience and independence. And so we saw an explosion of CSAs. Our food banks started integrating regenerative grow systems into the food bank to help our most socioeconomically challenged populations. As we saw, 150 million new families in poverty over the last 14 months globally. And so there's this massive, demand for resiliency to be built back into the food system, and the CPG companies all the way down to the growers are wanting to be a part of that. So I'm very thrilled that we're having a literal grassroots movement starting to kick up around this, where there is no bad guys anymore. There's only cooperative opportunity, and I think that's where we need to stand. The science isn't there to damn the chemicals. The science is to give us a revelation of who we are and what we are. We are an ecosystem biology. And then when we embrace that in our food system, we're going to eliminate the need for these multi-trillion-dollar disease management systems. We're going to plug our economies back into resilient, regenerative food as the primary economic driver, rather than disease, cancer management as the primary driver.
Thank you for the little sliver of hope. That is very much appreciated. Sean McGlone from National Organic Training is here as well. He has one question for you before we let it go.
Yeah, thanks, Zach. I was just going to ask you I read there recently that I think was it General Mills in the States were talking about paying a premium to farmers that were going to grow regenerative crops. Is there any evidence of that out there at the moment?
There's big evidence. It's moving. Yeah, General Mills is committed. Nestle is committed. Mark Schneider, CEO of Nestle, coming out of Europe there, has committed to 14 million pounds of regenerative organic produce in their supply chain by 2030. They have zero right now, so it gives you a sense of this is the moonshot of Kennedy and saying that by the end of this decade, man, we'll set foot on the moon. Our moonshot right now as humanity is to make a regenerative food system work by the end of this decade. And I am committed to that, making that effort. And so we're not only have the nonprofits, we've launched BioFarm Capital, which is a transformative economic model for bringing large-scale capital to become a generative communication system to solve for some of these pain points in making regenerative a international normal state by the end of the decade. So we need to mobilize capital in unique vehicles. We need to mobilize human ingenuity and ultimately collective creativity and ingenious efforts towards that single goal of adaptation and biodiversity in the food system.
One final question then, please, before we let you go, from John Garrity.
Okay, Zach, many thanks. Very interesting presentation. We're actually based here in Ireland for the conference. And I just wanted to ask you a question that might have a significant impact on those of us here in the coming hours. And specifically, I'm asking for Jack Nolan, but what's the effect of alcohol on the microbiome?
Well, despite my monotonous American accent, I'm actually Irish. So my family is McCutcheon, and my McCutcheon blood just like I could feel it bubble with that question. And so I am deeply committed to finding resilience in the microbiome again, so that the Guinness is no problem. Alcohol is obviously an antibiotic, does break tight junctions, but with a resilient and diverse microbiome, we will all enjoy the Guinness just as we did 30 years ago without the damage.
Thanks very much.
I wonder, does the scientific evidence support this analysis? Anyway, Zach, absolutely fascinating presentation. Thank you so much for your time. It really is very much appreciated. Please do keep questions of this nature coming in. We're going to filter them all. There's still 2 more presentations to go this afternoon and this evening, and we want to get as many of your thoughts and inputs as we possibly can into that. And coming up after this next short break, we're going to be taking a closer look at what the climate crisis benefits from regenerative agriculture are.